Today we're going to continue with 5.2, day 1. This is movie 3, where we're continuing with the football problem. A football is projected into the air, and we want to go ahead and graph this into our graphing calculator. So we're going to enter the 80x minus 5x squared into our graphing calculator. So we're going to go ahead and push the y equals button. And there might be some stuff in your calculator from before. So just go ahead and push clear and enter. And it will delete out that y equals to the right equation. Now we're going to go ahead and put in 80x, which is the button to the right of the alpha, xt theta n, minus 5x raised to, so that's the upside down b, and then 2, and then arrow over. Now let's go ahead and graph it. Problem is my window is not set up, so I have to go ahead and change that window. It looks like kind of a line right now. So if I change my window, I'm going to change it from -10 to 30, and then I'll just change my scale to 5. And then my y minimum, let's do -50 to 400. And then my y scale is every 50. And then let's graph it. So here is the shape of my graph. Now I can push the trace button like we did in the last problem and trace along there to find my maximum point and my intercepts. So this looks like about 8 and then 320. We'll just as my vertex. Then if I trace along, moving to the right, see my cursor, that x-intercept looks like it's about 15. So over 15, up 0. And then we go the other direction. We could scroll in a little bit too. Looks like that y-intercept and x-intercept looks like about the origin. All right, so let's go back to our slide now and graph it. So our x-axis is going to be the time that the ball is in the air. The y-axis is the height of the ball. And we have some pretty large numbers, so we want to change our intervals along the y-axis. So we may want to make every box here 50 units. So there would be 200, 100, 300, 400. Then my x-axis, I maybe want to make just every 2. So this would represent 2, 4, 6, 8, 10, 12, 14, 16, 18, as we move along like that. All right, so now if we graph the vertex, it's going over 8 and then up 320. That's about here. And then our x-intercept we said was about 15, 0, and then 0, 0. So here's the path of our ball. The first question is, where is the maximum point on the graph? The maximum point is where is the highest point on the graph, so that's the vertex. So that point that we found using our graphing calculator was 8, 320. Then it says, what is the maximum height of the football? So remember, the height is your y value on your graph. So the maximum height this ball could reach was 320 meters. The next question is, what time is this at to meet its maximum height? So that's along the x-axis. That height was 320 meters at 8 seconds. And then question 4. What is the height of the ball after 3 seconds? We haven't gone out and found that with the graphing calculator, but we're going to just make a rough estimate of what the height would be. So it says the time is 3 seconds. So where are we going to go on the axes? We're going to go across the x-axis over 3 units, and then read up on that curve to what the height would be. So let's go back up to our graph. We're going to go along the x-axis with the time, and here is about 3. And now I'm going to go dot, 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 and it looks like it's about 170 meters. Now this is just approximate. The last question, we throw the ball up in the air, when will the ball hit the ground? So imagine this is the flight of the ball, so let's go back up to our graph. Ball goes up in the air, comes back down. When will it hit the ground? The ball is going to be up in the air for 15 seconds. That is the x-intercept. Imagine the horizontal axis. This axis right here is when, if x is 0, that means the ball is on the ground. There's no height to the ball. So then when will the ball hit the ground? After 15 seconds. You're going to see problems like this in your homework tomorrow. I will have graphing calculators for you to use to do these problems. If you do have your own graphing calculator, that's great. You can start working on it tonight if you wanted to. If not, we'll work on it tomorrow in class. If you'd like to see what your homework is, if you want to get started on it tonight, here it is. Page 328, problems 30 through 34.